Hello everybody. I welcome you to a new course on mass, momentum and energy balances in engineering analysis. I am Pavitra Shandilya from the Cryogenic Engineering Center at IIT Kharagpur. With me will be my two teaching assistants, Mr. B. Nitin and Mr. Amit Rajkovar, who will be assisting me to conduct this particular course. Before I go on to explain the relevance of this particular course, let me give you some examples of some of the phenomena which we come across in our day-to-day life. So now you see this particular figure, you see that here we see the boiling of the water, and this we see every day at our kitchen also, that the water boils. And what happens during this time? That we find that when it's on the flame, the heat is going from the flame to the water, it is heating it up and the water is boiling, and during the boiling what is happening? Some of the water is getting vaporized, and ultimately we may find that over a long period of time then all the water will be going out of the vessel. So what is happening here? There are many things happening. One thing is this: there is a heat transfer from the flame to the water, and next the evaporation. And during this evaporation, the water molecules are leaving the liquid phase and are going to the vapor phase. And during this transfer from the liquid to the vapor phase, the latent heat of vaporization is getting transferred also from the liquid to the vapor phase. So we find that it is a simultaneous action of heat and mass transfer. Okay. Next phenomenon, which we also see quite a bit in our day-to-day life, you see that there are two beakers, and in these two beakers we have water. And what I am doing now, that in both the beakers we are putting some kind of dye. And you see in the first beaker we are not disturbing anything, we are just allowing the dye to spread into the water on its own. In the second one, what we are doing, we are stirring it. Now you see that when we stir it, the dye color gets distributed into the water much faster than when we leave it alone. Now this kind of phenomena we also see every day, like when you are making tea or coffee, the color of the coffee is going into the water or the milk. Okay? And similarly, when you are dissolving sugar or some salt in water, what we are doing, we are stirring it with some spoon. Okay? So in all these cases, what we are finding, that we are trying to enhance this spreading of these particular solutes, what we call solutes, like the sugar or salt or the dye, into the particular solvent, in this case that is water. So by stirring we are enhancing the rate, and this is coming under mass transfer, and this is a very common phenomena in our day-to-day life. Next we come to two things. The first one which we are seeing on the top is the sailing of a ship, and the second one is what we many times find at the cyclones, which were shown on the TV, that this kind of how a cyclone is moving from the seaside to the land, and these are very common. And in these cases what we are doing, that basically we are trying to figure out how the particular in the case of the ship, how the water is getting affected by the ship movement, and how the water in turn is also giving some kind of drag resistance to the ship, so that whenever we are designing and building the ship, we have to take into account the resistance that is being offered by the water, and the ship should have enough power to wade through the water. Similarly, in case of cyclone, we know that a cyclone travels sometimes whenever there is some kind of a temperature difference. That temperature gradient creates the cyclones, and they move from region of high pressure to low pressure. Okay? So this is the way the cyclones happen, and this also comes under what we call the momentum transfer. Okay? And another one which is also very common, here we see three things. One thing is the spaceship. We keep seeing the spaceships, that the rockets are being launched many times by NASA or ISR or ISRO. So we find that the rocket is moving upward, and during its movement we see fire is coming down. It's not fire, it is basically some exhaust gases. There's combustion, there is some fuel there, and the fuel is getting combusted, and it is being ejected at a very high speed, so that we can get some impulse. And by the Newton's third law of motion, that particular rocket is being propelled upward. Okay, and in the other two figures, what we find, there is one helicopter and one aeroplane, and in case of both these cases, we are designing some propellers so that the helicopter or the aeroplane can maneuver themselves at some particular direction, or they can also move away from the land, also or during takeoff, or they can also land when they are trying to come towards for the landing, they come towards the earth. So all these kind of movements, all these kind of things are being designed considering the momentum transfer or the interactions between the surrounding air and the particular object. So when you want to go for such kind of design, such kind of analysis of these systems, then you need to know how the momentum is getting transferred, mass is getting transferred, or energy is getting transferred. This particular course addresses these three issues. So you can see that this course pertains to not only to our day-to-day life to explain many of the phenomena, but also in the industrial scale also many processes can be explained if we know how to make the energy balance, mass balance and the momentum balance. These kind of things you also encounter that when you are learning fluid mechanics, when you are learning heat transfer or mass transfer or transport phenomena, for which you have separate courses, there also you are using this kind of mass, momentum and energy balances, which are basically based on some kind of conservation law of mass, energy and momentum. And in this particular course, we shall be looking into these kind of fundamentals. So what we shall learn from this course is that we shall know how to derive the mass balance, energy balance, momentum balance for different types of processes, and these processes are basically which we find in our industries or we find in our day-to-day life. And next we will also learn a bit of not a very in a extensive manner, but some basic techniques to solve the equations which we obtain after writing the conservation equations. So who are the persons who may register in this course? It is for all the engineers and scientists who are involved in the analysis of the various types of processes which involve flow, heat transfer, mass transfer or chemical reactions. So it is pertaining to the engineering students of both undergraduate and postgraduate level. They may take it as their core subject or as an elective. It is also meant for all the research scholars at various levels, whether at institute or at some research laboratories, and also for practicing engineers and scientists at the industries. Now, what are the benefits? That we will be kind of either getting introduced to the various conservation laws of the transport phenomena, or we may be revising the things which we have learnt in our undergraduate for these particular conservation laws. And we should be able to derive and make the conservation principles applied on the various types of processes. And lastly, we shall also get to know some basic mathematical tools to solve these conservation equations. Now, after learning all these things, what's the benefit? We find that when we learn how to model the various processes based on the mass balance, energy balance, momentum balance, we will be able to design a new process or develop some new process. We can rate a process, that means assess a process, it's whether the process is working properly or not as it is supposed to do, and then revamp a process or control or optimize a process. All these things can be done if we know how to make these three balances, that is how to apply the conservation laws to the practical processes. Now, what are prerequisites? The prerequisite is very simple, that we need to have a good grip on our high school level science, that is basically physics and chemistry, and with that we can go about to learn this particular course, because in this physics chemistry thing we learn about the various types of Newton's laws. We learn about Newton's first law, second law, third law, and also about the mass conservation, some basics of the thermodynamics like zeroth law, first law, etc. And in chemistry, we learn some basic knowledge about the reactions. So all these things will help us to learn this particular course. I hope you will enjoy working with me to learn this particular course, and please feel free to interact with me as and when you have any kind of problem, that so that this particular course can help you to enhance your knowledge in going for a practicing engineer, to develop yourself as a good practical engineer or scientist. Thank you.